Hello and welcome to this film about dative bonds and electron deficient molecules. Now hopefully you've just seen the film about drawing electron dot diagrams for covalent molecular substances. This film deals with molecules where those electron dot diagrams can seem a little bit odd. Okay, so we're going to look at examples of molecules where there are bonds in which the electrons have come entirely from one atom instead of being kind of shared, one each. And we're also going to look at things called non-octet molecules. So, to start with, something that we touched on very briefly in the film about drawing electron dot diagrams, we looked at bonding capacity in electron dot diagrams. So we were using as a kind of check in one of the examples, looking to see how many bonds each atom had formed and whether it made sense. Now in water, if we look at the electron dot diagram for water, which we should be able to come up with for ourselves by now, just to point out here that the bonds have been shown as lines and the electron pairs as dots. There's no need to draw them differently, but this is perfectly acceptable. What we can see here is that oxygen has formed 2 bonds and each hydrogen has formed 1. Now that makes sense because hydrogen can take 1 more electron to fill its outer shell, so it can share 1 electron and form 1 bond, whereas oxygen has 6 in its outer shell, so it can take 2 extra and share 2 and end up with 2 bonds. Okay? Now that's normally quite a useful check, and it normally kind of tells us that things are working as they normally would, I suppose you could say. However, there are molecules where that rule doesn't get obeyed, and yet there's nothing wrong, you could say. Okay, now if we draw an ammonium ions electron dot diagram, we'll see that it looks like this, with nitrogen having formed 4 bonds to hydrogen and an overall positive charge. Now, this might strike you as odd if you're doing your little check, because nitrogen, with its 5 electrons in its outer shell, ought to, so to speak, only form 3 bonds. Okay? But it's forming 4 here. Now if we look at this diagram and perhaps think about ammonia as well. So if we drew an electron dot diagram for ammonia, which is NH3, then we'd end up with something that had a lone pair on the nitrogen and 3 hydrogens attached. Now that looks a bit better according to our check because it's formed 3 bonds. But if we look at the ammonium ion here and compare it to the ammonium molecule, okay, what we'll see here, if we look carefully here, the nitrogen's electrons have been represented as red dots, so there were 5 of them to begin with, and the hydrogen electrons have been represented as blue dots. There was 1 on each of those hydrogens, but there doesn't appear to have been 1 on this hydrogen. Now, if you think about what you've got to do to turn an ammonia molecule into an ammonium ion, okay, you've got to add an H plus ion. Now an H plus ion is simply a hydrogen atom that's lost its outer shell electron, a bit like this one here, has no electron of its own to contribute. But the nitrogen had a lone pair, so if it gives those 2 electrons to the hydrogen, in other words, if they end up sharing this pair that was entirely a nitrogen pair before, then this bond can still exist, but it's come from the nitrogen. In other words, the nitrogen gave the electrons to the hydrogen. It's called a dative bond, or a coordinate bond is another name for it. Okay, and sometimes, but not always, on electron dot diagrams, these are shown as an arrow, showing that the pair of electrons was being given from the nitrogen to the hydrogen instead of being a pair that was equally shared. Okay, so that's what we mean by a dative or a coordinate bond. This comes up quite a lot in the periodicity topic when we start looking at complex ions. Here's another example of a molecule that's got a dative or a coordinate bond. If we draw the electron dot diagram for carbon monoxide, we'll see that it's got a triple bond between the oxygen and the carbon and a lone pair on each of them. You can figure this out for yourself hopefully by now. Okay, but if we look again at what's happening here, carbon has formed 3 bonds, but it's in group 4. It's got the possibility of forming 4 usually. Oxygen's in group 6, so it likes to form 2 bonds because it's got room for 2 electrons. but it seems to be forming 3 here. So there's something odd happening, and perhaps we can explain this again in terms of coordinate bonds. Well, again, this diagram helps us do that, because instead of showing all the electrons as being the same, it shows us the oxygen's electrons, so these are the dots. Oxygen started with 6. Oxygen started with 6 electrons. In order to form this structure, it must have shared 2 of them, so these 2 that it shared and got something back from the carbon are normal covalent bonds, but one of these bonds has been formed by oxygen giving a pair of electrons to the bond all by itself. Carbon didn't contribute anything to that bond, so you could say that one of these bonds is coordinate, and you could draw an arrow on it to show that. You don't have to do that in your electron dot diagrams, but that's what we mean by a coordinate or a dative bond. It's a bond in which the electrons came solely from one atom. They didn't have a contribution from the other one. Okay, now there is one other type of molecule in the SL topic, that is, that looks a bit odd when we're drawing electron dot diagrams, and that's boron trifluoride. It also happens to be the case for BCl3 and other boron molecules. Okay, now because boron is such a small atom, it kind of bonds in a slightly strange way. To cut a long story short and to be deliberately a bit vague about it, boron is odd. Okay, now if we draw an electron dot diagram for boron trifluoride, we'll end up with this structure here, and it's impossible to make it make sense in terms of having an octet, or 8 electrons or 4 pairs of electrons around boron. Okay, and boron is unusual in the sense that it will accept having less electrons than other atoms. So in other words, this molecule looks electron deficient. It's also called a non-octet molecule because there isn't 8 or 4 pairs of electrons around boron. And luckily, the examples of non-octet molecules in the standard level course there's a very small number of them, but these 2 are ones that you should definitely remember. Okay, so we've had a look there in that film at a different type of bond to a normal covalent bond called a dative or a coordinate bond, and we've also had a look at a couple of molecules that don't seem to have the right number of electrons in them. Okay, just make sure that you remember these things. There's not a huge amount of these types of molecules to encounter in the standard level course, but it is important to remember them. If there's anything that we've been through here that doesn't make sense or you want to comment on, then please feel free to post on the YouTube channel, or of course to come and see me in person.